Hello, good morning, evening, afternoon, wherever you are in the world. Hope everyone had a good New Year's. Wait for people to start rolling in. We'll kind of go over what we're going today. We'll go over what we're going to go through today. A little less OpenGL today. A little bit more C++. For anyone who's been around a bit, I've mentioned before what we're going to be doing today. I guess as a quick recap. Let's see over my little mini preview thing that I set up. Kind of got a pretty good rendering pipeline set up now. It's pretty basic, but it's pretty okay. It supports multiple lights, some arbitrary sort of model loading, skybox, HDR, gamma correction, a whole few things. So yeah, let's wait for some people to roll in, see what we get to. You know nothing about computers, but you find the videos interesting and understand other words. Well, today's going to be quite reasonably heavy-ish on the computer terms, but I'll explain it as we go along. Hopefully, you find it interesting. It's going to be, I don't know, semi-advanced C++, I'd say. Not too bad. It's actually the specific thing I want to do today is actually a great project to do standalone. So, kind of hopefully give people some ideas of what we want to do. Queco, hello, resubscribed. Thank you very much appreciated. I'm a real streamer now because I have a stream deck, so I can be like, I know I've hooked the lights up to it, so and a few other bits and pieces, in case that's useful. So yeah, let's start. If I press my fancy button. I've gone back to the sort of pink circle, but bottom right seems to be the preference, kind of out of the way of the code. So yeah, we got a game. We can kind of, well, I say a game, good one. We've got a simple scene. It just renders a load of barrels. As you can see here, it's got some sort of sense of like dynamic lighting. We can move these lights around. We can adjust the various features of the lights with this little debug UI that we built. Change the gamma if we need to, those kind of things. So that's kind of where we're at. The problem we have at the moment is the the scene loading and the model loading. So if we go back to main, where do we do it? We have a mesh loader class which loads meshes and caches them, and internally that uses, I can't find it now. Where's mesh loader? Mesh loader, here we go. Internally that uses Assimp. It uses a third-party library called Assimp, which is kind of okay. It's pretty good. It supports a lot of file formats, so we don't have to worry about parsing FBXs and objs and all those kind of things. But it's, especially in debug mode, it's a little bit slow. So when we build and execute it, we'll see here that it kind of, well, the building takes a bit of time anyway. We might be able to improve that in the future, but like here, like this, probably can sort of see slightly off screen, the windows popped up. I can't actually interact with this because it's locked up, because this is just processing mesh files from the disk and loading textures and doing a whole load of chuff, which then we get the game, which every time we do it is a bit of a pain. What I kind of want is to create a custom file format that we can ship with the final game, or embed it in the executable. How you get that custom file is kind of irrelevant, a problem for another day, but it's a custom file format that has basically the data in a format that the game can easily consume and load. So the idea is that it kind of has all the vertex data for the meshes already in the right order, already packed out, whatever, and you can just mem copy that into a vector of vertex data, and that's your model. The same for textures. So I mean, I'm not a game dev, I've never worked in the game industry. I would assume that most engines or most games have some sort of concept of this. I can't imagine they are processing FBX or whatever files every time. You know, the idea is we want to pre-process all that once and then just ship all that in a nice format. So the plan of attack is to develop a custom file format and create a reader and a writer for it. I think that's probably the fun part. So we'll get that done first-ish. And then after that, we will have to integrate that with CMake so that when CMake runs, or when you configure CMake, it will run through your assets directory and build out this file. And then we might need some sort of like manifest file to kind of say which of the assets in the directory we want. So there's some fun stuff to do to start with, and then there's a little bit of plumbing. So we'll kind of just see how far we get today. Yeah, it might spill over to another stream. We'll see how it goes. Okay, so there is a myriad of different ways of bundling like arbitrary binary data. You know, you can create, like, you can stick all the binary data into like a big like blob, and then you can have like header files which have offsets into it. You could, you do stuff with compression and stuff like that. Like, there is a way that I want to do, just because I know I find it's kind of easy. It's easy to implement. It's reasonably easy to verify, and it gives, I think, reasonably good performance across reading and writing. It's probably slightly slower on the reading potentially, but I don't know. It's kind of fun. It's kind of fun to write some data structures, and we'll kind of go through all that. And I think, as well, for me, there's some kind of modern C++ goodies to be had from doing that as well. So we kind of go through some more C++ stuff. If we need compression, I will probably lift a library, like a fast one that's probably fast to decompress. I don't think we're going to need it to start with. I'm not that fussed about binary size. That is gold plating in my mind. But yeah, I'm not sure if anyone's ever heard of a type length value, sometimes called a tag length value, but it's a way of, basically, it's an encoding scheme where you encode in a fixed number of bytes a type, and then a fixed number of bytes a length, and then that many length bytes the value. So we can basically say, encode me a string, it has this many characters, and here are the characters. Or we could say, encode me an RGBA texture. It has this many bytes, and then here are the RGBA texture. Here are all the RGBA tuples. So we're going to basically roll our own one of these. Again, like, I'm sure there's libraries to do this, but I think this would be a bit of fun, something interesting to start the new year with. So yeah, we'll see. I think we'll just start writing, as always, we'll just start writing some code and see where we get to. I'll answer questions as I go along. I'll certainly make some mistakes as I go along, and we'll see where we get to. So I think I'm going to do the reader first, because I think the reader is more interesting. Writing is just shoveling bytes around and then sticking them in a file. I think reading is kind of where the devil in the detail is in the reading, because you've got to make sure that you are correctly passing this. You're not overextending your buffer. You're not correctly, you're not incorrectly handling types. So yeah, we're going to start building that out. What are we doing today? You've just missed the intro. We're going to write a simple encoding scheme or custom file format. Depends. Whatever you want to call it, for encoding game assets. So eventually we'll have an asset pipeline where we can just bung all of our assets in a directory, and then CMake will automatically pick those up, stick them in this custom format, and then make them available to the game, and then the game can at runtime consume those. That's the plan. So I'm going to start with the reader, because I think that's the most interesting one. Also exciting, I have now got a new keyboard, which is much more clickety-clackety. So depending on whether you like that or not, I don't know, but I like it. Okay. We'll probably have to fiddle some stuff around in the structure as well, because we're going to want to write a packing utility, which we'll probably do that all in C++. Because just to keep it consistent, and we'll want to share various header files between the two. So I think what we end up might doing is rebuilding everything as a library, and then having like a game exe which just drives that, and then any of the tooling can also link against that library to have access to like, the various bits and pieces that we've defined. I've not really thought much about Git actions or kind of any like any of the tooling or the chuff that goes around with actually packaging it. I think that'll be a stream in itself. Like, how do we actually bundle all this up and build it, and do a release build and kind of get all that going. So we'll see how we get on. I'm also trying out some new some new software for combining chats from Twitch and YouTube, and it seems to not be working, which is exciting. So apologies if I miss any messages. I'm getting the Twitch alerts, but I'm not getting Twitch messages, and I couldn't really tell you why. I don't want to spend too much time debugging this because that sounds like a pain. Twitch. Apparently I'm only partially connected on Twitch. I don't know what that means. Yeah, it's definitely not seeing my Twitch account. I have zero interest in debugging this live. Platforms, Twitch, accounts. Says I'm connected. Fine, whatever. I'll just keep an eye on both. Apologies, and Twitch if I miss your comments. I'll do my best to keep an eye on both. Which would you say is easier to reverse engineer? Programs that use DLLs or programs that use static libraries? Well, I guess because the difference is like what you end up at the end with, right? So when you use a static library, it all gets included into your executable. So there is what you ship and what you run, there is no differentiation between the program and the library because it's all being combined into one. Whereas a DLL is shipped separately in runtime linked against. It's all just assembly at the end of the day. I don't think it makes too much of a difference. I guess separate DLLs might be simpler because you might be able to conceptualize and kind of compartmentalize like buckets of logic. Oh, this DLL does this, so I know I don't have to worry about it. And this DLL does this, so I know I don't have to care about it. So it might help you kind of weed through the, where you want to focus your time potentially. But it really depends how it's designed. Like if someone's thought about it and they want to kind of make things difficult, they could spread logic across all of them in like miserable ways. So you never really know. So I guess if pushed for an answer, maybe DLLs. I guess the advantage of DLLs is it might be easier to kind of patch or hook because the game is going to be searching for that named DLL, so you might be able to replace it with your own one potentially. Structs sole purpose compatibility? No. So the difference between a struct and a class in C++ are exactly the same, like identical, except for the default access modifier. So by default, everything in a struct is public. All right. So I'm also getting used to my new keyboard, so I might be even worse at typing than normal. So with a struct with S here, anyone who creates an S can access and mutate X because it is the equivalent of this. Like those are the same, but in class it is private by default. So those are the only two differences. Like conceptually, I tend to use structs for like bundles of data that I know I want to mutate and won't have any methods on it, and then I use a class for everything else. But that's kind of my personal convention. Happy New Year, yes. Okay, so what I'm gonna do is, for this, I think we're gonna have a span and a c_def. c_def. Okay. And then here again, like before, I have to, if I want someone to use this, I need to declare it public. So we'll have a constructor which takes a std span const std byte buffer. And then we will do what we're going to do. We're going to do private, and then we'll just create a std span const std byte buffer. So yeah, TLV stands for type length value or tag length value. It's just a way of, it's just a super simple binary encoding where we can basically build up some primitives to encode arbitrary data. You'll see kind of how it all reifies when we actually get to do it. So yeah, today we are just building up a custom schema for encoding assets in our game. I want the reader to be lowercase v on line 12, but up on others. Oh yes, bottom. I want the reader to be non-owning. Like, you should be able to just give it a span of bytes. So a span is a non-owning contiguous range of an object, so in this case bytes. So this is just a non-owning view over a bunch of bytes, and you basically say there's a TLV in that, and then we're going to use this class to kind of interact with it and iterate through it and search for things, and we'll do all the verification along the way. We will keep the contracts quite narrow, in that we will do a lot of error checking along the way, because this is effectively user supplied code, and we won't trust it. Although we are building it ourselves, I wouldn't want someone to kind of mess around with that in any way. So yeah, we'll see that we do quite a lot of error checking along the way, rather than just sort of, you know, failing fast or whatever like that. So what we're going to do, so I think the reader is going to want to read entries. So let's source TLV entry.h. What we'll probably do as well is build a lot of this using unit tests, because we actually, I mean, from like a very early stream, we do actually have unit test framework set up. So we'll make use of that, and because it's kind of, it's very easy to test. It's just bytes, right? And we just check that we process those bytes correctly. So enum class TLV type. So this here is going to be an enumeration of all the things that we would ever want to store in our structure. So I'm going to go like uint32 and string. So I'm just going to start off with those. We'll probably eventually want to add like a vector3. We'll want to add arrays of objects. We'll want to add UVs, you know, all the things that are very specific to our game. But we'll start off simple, and we can just, you know, expand it from there. And eventually we might even want to have just like a texture, which means, you know, which has like a type and a width and a height and a, you know, all sorts of other stuff. So if we do this right, we can basically figure out how to decode primitive types, and then we can build out aggregate types from there. I'm also going to, because this is all like int, because this is all very specific to no, what am I trying to say? Because we care very much about like serialization and sizes of things, and, you know, making sure that we don't, you know, read too much data or extend beyond any buffers, I am going to actually be explicit in a lot of cases about the sizes of the things that we want. So this is going to be a std uint32t, So this basically says whenever we create one of these enum types, make sure it is 4 bytes. I mean, obviously, if we wanted to save space, we could go back and tweak this because we probably don't need 0 to uint max 32t options, but I'm going to stick with just kind of 4 bytes for everything to start with, and then we can, we can tweak it from there. Is every byte struct going to be a single asset, or are you going to pack multiple assets into a single byte array? So the aim of this at the end of this is to have one massive byte array which has all the assets in, but enough kind of machinery around it such that we can iterate through it and find the ones we want. So if we say in the game, oh, I need barrel normal map.ping, we can basically we can give that massive buffer to the TLV reader and we can search through and find it. That's kind of the end game. We'll see how much we get done today. I think there's quite a lot to do, especially a lot of like nitty-gritty integration things at the end. So, we'll see. But like I said, I thought start off the year with a bit more C++, maybe a little bit less OpenGL. Okay, so then we're going to want class TLV entry. So this will represent a single entry in the structure. So one thing that we can code. So one of these, it'll either represent a uint32, or it will represent a string, or it will represent any of the other complex or aggregate types that we add afterwards. But this is kind of where we're going to get started with it. So add some access modifiers, and then bring in some of the other chuff that we need. So in my mind, I kind of want to keep this as like non-owning as possible, as in like minimize the amount of copies. So we got this massive buffer, and we should be able to just kind of using like reasonably modern C++, we should be able to just create views and sort of slide over this until we find the data that we want, and then when we're kind of happy that we've found the data that we want and it's the right size and there are no sort of errors or anything, or corruption, then we can kind of copy it out and give the game a fresh copy of it. It may be that we choose to keep a non-owning view of that out of this, but I think for now that's kind of in my mind where I'm going with this. We don't want to be sort of copying loads of data around until the point where we've actually found the specific thing in the schema that we want, like in the packed data, and then we'll pull it out then. So actually, what do we want? So a TLV will have, like we said, a T and L and a V. So we'll have a TLV type, and then we'll have a stud uint 32t length, and then we'll have a stud span of const byte value. So this is our T and our L and our V. And again, it's 4 bytes, and then some number of bytes, and the size of that is in the length. I'm trying to think, we might not, do we even need to keep track of the length separately? Might not need to, because the span will effectively do that for us. So maybe we can get away with that. Yeah, I think that might be right. So the TLV entry will have TLV type, and a stud span const stud byte. I should probably alias that away, but here we are. So we'll construct those and we'll set them, and then at the moment, the only way we can kind of get, the only thing we'll have is a auto type const TLV type. So I'm not exposing this to the user yet. This is kind of internally like the range of bytes, and at some point we'll want to trigger this to get a copy of the data out. Yeah, exactly. Well, that's strings, they have variable length. Yeah, sorry, you're right. Well, this would have a variable length and stuff. Actually, I'm just going to keep it simple and just specify the length separately, because we'll see when we encode this that these will be encoded as separate lines. Or do we need that? Or am I overcomplicating things? No, actually. Sorry, I'm figuring a lot of this out as we go along. This can have a variable size, right? So the question was, what about strings? They can have a variable length. This will have some number of bytes in it, but the object itself, the stub span, has a method on it called size, which will tell you how many elements are in it. So that's pretty good as a starting point. What I think I want to do is kind of lean quite heavily on iterators for this. I think we should be able to iterate through our we should be able to construct a TLV reader and iterate through it. And if we can do that, then we can leverage the rest of the standard library to our advantage. We can use find, we can use contains, all those sorts of things. So I think if we can kind of write our code in a way that is convenient for the rest of the language, then we can kind of reap a lot of benefit from that. Oh yeah, sorry, this is the after it's been decoded. I think we might, so this is kind of like the user side of the code. The writer will probably just be, like I said, the writer is less interesting. I think it'll just be a class called writer, then a bunch of methods which are just like write int, write string, write this, write that, write this, write that, and internally it will just consume and create a buffer. Sorry, it will just append to a buffer, and then you'll be able to just yield that out at the end. Yeah, no, I think it's a good point. Yeah, so the binary data itself will have an extra entry for length, but we don't need to effectively duplicate that here. Okay, and then I think we kind of nearly got enough to get going with. So after we've got the type, we can do, we want to be able to get the value out of it. So there's kind of two ways we could do this. We could do template class T and then do auto value const T, right? And then we could be like, if const expr stood same as T stood uint 32T, get value as uint, and then we could do like the same for like stood string and vector 3 and matrix 4 or whatever else we want to do. And then I guess the kind of like the interface for that is not too bad, because you could just do entry dot value stood string, right? And they'd be like, hey, can you just get me the value as this? And then internally we could check that the type is correct and pull the data out in the specific way. The problem with this is I think it's actually kind of unnecessary. So my this is where my brain goes to first, because it's like templates, and that's just where my mind often goes to. I think this might be the incorrect usage for templates in this case, because it's not obvious to the user what the supported types of T are. I mean, obviously at the end of it we could have like else static assert false, right? So we could just be like, if the user has given us a type that we cannot deserialize to, we'll just fail to compile, which is fine, but I don't think that's particularly intuitive, because just looking at like this, you'd be like, oh, what I could, what type do I give it? So I think actually a better way would be, and also that function is just going to get, excuse me, get longer and longer the more types we have, and they all have different ways of serializing, deserializing, and we're just going to be applying like more and more data onto it. Sorry, more and more code onto it. So I think actually if we just explicitly have like something like that, then we can basically say, hey, I've got this entry, this almost like a view into the data. Can you please get it to me as a uint32? And then inside that we can check, have we got enough bytes? Is the type correct? Okay, then we can return it as that. So I think it just kind of keeps all the code a bit more compartmentalized. and it still means we have to add a method for each one of these types that we add, but we'd have to just bung that inside a templated function anyway. So I think this is better. I think. Yeah, sorry, a couple of questions have just come in. So what's a TLV? A TLV is you can look it up on the Wikipedia page. Is absolutely terrible. I think it's not great because it doesn't really give you any information about really how you would make this. It's just like, I guess go look at the implementation of TLS if you want to see a real world example of this, which I would say don't go look at TLS for an example of anything because it's incredibly complex code. So that's what we're doing. Does C++ have yield? It does have yield, but only if using coroutines, and that is an entirely separate kettle of fish. I would like to do some stuff on coroutines, but they are, because C++, they are miserably complicated. I think they are. There's a huge, like an unbelievable amount of boilerplate you have to write to get coroutines to work in their current incarnation in the standard. But they are good fun, and I'd like to do them, but we don't need coroutines for this. Apparently I'm dropping frames. Apologies. Everything says good and excellent. Hey, see, glad you're here. So wouldn't using the enum to get the value of a certain type be better than just switch on it and the user knows what type there are from the enum values? Yeah, but like, what would your return type be? So I think you're saying something like auto value TLV type, right? And you go like switch type enum TLV type case uint32. I guess you effectively, return as uint32t. I think it's the same problem because this is just a template because it's got an auto return type. So you could. I don't think this would work because on every return statement, you would have a different type, and the compiler would be like, you've got multiple paths returning different types. I don't think you can. I'd have to check. I don't think you can support multiple return types without context per if, as in like to selectively not compile the other ones. So yeah, I don't think that would work. Like I said, there's a whole bunch of ways of doing this, right? You could have a variant of all the different types and just pack one of them into it. You could you could give someone a void pointer and promise them that there's the right bytes on the other end. Like there's a million, like because C++, like you have all the options available to you. I'm just going to kind of pick one that I think is sensible, have a go at defending it, and then implement it, and we'll see where we get to. So I'm using ClangD as the like autocomplete red arrow thing, which is why this is a little bit grumpy because it needs updating. But I'm actually building with the wine version of MSVC, so I can cross-compile for Windows. I think this is fine. This is what I want to do because it's super explicit for the user. Hey, can you give me a uint32? And then inside will be like yes or no, depending on whether we have the data or not. Let's implement some of this, and then we'll write some tests, and then we'll see where we get to. Have I named my files incorrectly? I think I have. I'll fix that in a minute. I'll fix it now, actually. To entry.h. H, and then was there another one? Yes. TLV entry.cpp. Okay, cool. TLV entry, TLV entry. Okay. Oh my goodness, what's going on? Alright, okay, fine, here we go. Stick us all in the game namespace, which is not particularly well named, but it's what we've got. And then use my usual trick of just bringing these in, and then we can go in TLV entry, and then hopefully we can just do that, and then that, and then that. Okay, that's enough to get us going with. And then I'm going to want a bunch of these headers as well. All these red miserable squiggly lines disappear when I actually build it, and it updates the compile commands JSON file. Okay, so for the this is just like pretty standard C++ chuff. We're just going to store a copy of the arguments. Again, they're pretty cheap to copy, just integers, and a span is normally just a pointer and a size. So at most we're copying what, 12 bytes, not too fussed about that. And this will be return type. So I guess hopefully now we can get to this point, things might start making a bit more sense about like what we actually, like what am I actually chatting about? Like what does this actually look like? So in the binary there will be encoded a type, right? Which will be like OX. So assuming we're doing this one, right? So this defaults to 0. So have 0 encoded. Okay. And then it'll have a length. Again, this is what the binary will actually look like. So we'll sorry. So this is what the actual binary will look like. So this is what we're going to effectively pass. Although actually at this point we could probably pass it, so we'll just have the value. But I'll just put it here for illustration. So the type will be 0. The length will be 4. Because the size of a uint32 is 4, and then our actual value will be OX, whatever, like will be 4 bytes, A, BB. Okay, so at this point the TLV is kind of, the reader would have done a lot of this for us and would have pulled out the type and converted it to an internal type. So this is what would have been passed in the constructor. It would have pulled out the value and the bytes into the span. So we're kind of in a pretty good place now. All we've got to do now is check that the remaining bytes are the right size for the type that we want, and then just copy them out. Let's do error. So all we want to do is ensure that value.size is equal to size of stood uint32t, and we also want to ensure that the type is equal to TLV type uint32t. Incorrect type. And then this will be incorrect. I'll probably go through and tidy up some of these error messages later. And then we're pretty happy now that this entry does indeed, there's no shenanigans going on, there's no malformed or data or whatever. You know, we do have the right type and we do have the correct size for it. So then all we have to then do is just squirt those bytes straight into the value. So we can then do value dot data, size of value, and then return value. And that's pretty much it. We check that we got the right type, we got the right number of bytes, we create a value, zero initialize it, and then we just copy over the bytes from the buffer and return. How would you ensure so the question is, should you ensure the result? Like, what would I be ensuring? I don't know a priori what value someone has stuck in this. All I know is that it's just a 4-byte integer. There's nothing for me to kind of ensure on. A string is very similar, so this will have the length of the string and then, you know, some number of characters there. So let's just get rid of that. So again, here, string. There is no size check this time because, as someone correctly pointed out, strings could be arbitrary size. Can you bitcast from a span? That's a good point, actually. You might be able to, the bitcast might be better. I'll have to double check that. Because bitcast effectively just wraps a mem copy anyway. The problem is I think it takes it as a reference, not as a pointer, and I don't have... Yeah, I can't bitcast because I only have a pointer to the data. I don't have a reference to it. So again here, like, the string could be any size. So all we need to do is just copy that number of bytes, which could be 0. We could support an empty string. And then we'll copy it out. You could check the last byte of the string is 0. So because it's my format and I make up the rules, I'm saying that there are no null terminated characters in the string. It's absolute size. So that's the point of the L in the TLV, right? It's the length of the number of bytes. So there's no need for a null byte, which means technically we could also embed null bytes in our strings if we wanted to. So you can't really memcopy here because this is going to be a string, and you can't just kind of memcopy over a string. We could reserve the length bytes, but what I think is actually easier is to do const auto reinterpret cast const char star value dot data. All right, and then we can just return std string pointer plus value dot size. Check my working, but I'm pretty sure that's a valid constructor for string. It's just like a range of contiguous bytes that represent the string data. We know that this will be the first one, and we know that the last one will be the size bytes afterwards because the length is encoded in the span. I think that's probably enough to kind of start pulling some data out. Let's see if this blends. So MNOPQRS, because that's how I remember the alphabet. I think that's the only CPP file we've got so far, right? Let's just see if it builds without running it. Have I got rein? Apparently I have reinterpret class from uppercase T, but I don't see it. Oh, I see. Right, sorry. Someone was telling me how I misspelt it. Thank you. Oh my goodness, so many typos. 919. Uint 2. Line 38. Oh, we've already covered that one. Okay. Different redefinition basic types in well done. TLV SF TLV entry. Oh yes, sorry. I see what you mean. Yeah. Yeah, it's just classic C++ errors, right? All the compiler has given me everything it knows that it thinks might be useful to me, but it just kind of it has a pretty poor signal to noise ratio. Okay, cool. So give that a quick fix. So this should make those errors disappear. Cool. Okay, so we should unit test this because I think that's kind of going to be the best bet. Sorry, our best bet going forward. If I can remember how all of our unit testing works. Tests. So I want test.cpp hash include gtest hash include TLV entry test TLV simple. I always like to just like check my cert true false, like just check the plumbing on the tests first by write a deliberately failing test just so I can see it and I know it's kind of all integrated. It's been some time since we've looked at this. Those are in the wrong order, which is annoying. About to put another one in the wrong order. It'll be test.cpp. Okay, let's see if this blends. Love unit tests, but hate writing them. It's just the way it goes. It's just the way it goes. Okay, right. Nice. Okay, right. So now we can start having some fun with it. So let's test against the, see if we can write some tests against the interface, because that's kind of the user-facing bit, and try and avoid too much guilty knowledge of the internals. So let's do ctor const auto entry equals game TLV entry game TLV type uint, and then I think I can just give it an empty span, and then all I want to do is assert equal entry dot type game TLB type uint. Pretty simple first test. Like, let's just check we've set the constructor up correctly. Unresolved. Oh, have I think this is just a plumbing issue for the unit tests. Where does it actually include? Oh, shoot. So far I've only been testing header only code, so I've not had to actually build anything in. That's annoying. The correct way to do this would be to rebuild everything as a library and then link it against it. But that requires an awful lot of plumbing, which we will need to do anyway when we come to the other one. So do we do this now, or do we just fudge it for the sake of the tests? The issue is that the unit test executable that we've built, right, and that we're running, has no concept of, like, doesn't know about the code. Someone said now, you are probably right. So add library, gamelib, and then OpenGL static, and then add library gamelib, and then add executable game main.cpp. I'm glad someone out there is keeping me on the straight and narrow, because I might have been tempted to be like, I'll fix it later. So all this does is now bundle everything we have into a static library. We're going to create executable here. We need to make sure that this is duplicated for the gamelib. Do it first because I defined it first. Not that it makes any difference. Okay, this is almost certainly not going to work first time because I would have missed something. I think the game doesn't need to know about STB, doesn't need to know about a lot of this, doesn't need to know about imgui, does need that, does need that. So, and then we can just do, so in fact actually this just becomes target link libraries gamelib. First tech debt of the year. Okay, could even work. And then now we should be able to do target link libraries here. Gamelib. So this will just, because all of our code is now in a separate library, we can link that against the unit tests and it should have access to it. Let's see. Everything is public on the lib, so no need to set on the exe. Yes, good point, actually. That is an excellent point. I was not expecting that to just be, that's so easy. The point here isn't, by the way, I mean, I'm not C++ expert, but I'm even less of a CMake expert. Because I've defined all these as public, it means anything inheriting from it, anything linking to it also inherits those. So I think that's all we need. I think that's what we're saying. And now we wait. Okay, cool. Okay, right. That was not. I made that out to be so much worse than I thought it was going to be. Apologise for my sensationalizing of the amount of work that we had to do today. LV reader entry, right. Okay. So now we can do test TLV unit HTTP value. So we'll just check this works. How long have I been using CMake? It looks like a good alternative to fighting with writing my own makefiles. I've been using CMake about as long as I've been using C++, but I've definitely gotten better at C++ than I have at CMake. I think, yeah, and I think that's quite, unfortunately probably true for a lot of people. Like, is a tool at the end of the day, and I think, you know, I have a lot of respect for people who are very good at it. I wish I was better at it. I know enough to be dangerous, and that's kind of about it. It is infinitely... It's mostly better than writing your own makefiles. If your makefile is like 5 lines long and you don't want to turn that into 20 lines of CMake, then I totally get that. For anything complex, I think for anything with more than one file, CMake is a better option. I've never used Premake, so I have no opinion on it. Okay, so let's grab one of those. And then, well, we're actually going to need some bytes now, so let's do... I include? No, you include. Include vector, include span, include cstdef. Oh, we'll treat ourselves as well. Well, as it is the new year, we'll have a cstdint. We'll also have a string. Okay. So we're going to need some bytes. So const auto bytes equals std vector std byte. So here we can start laying out the bytes that we want. So if we want it's true, I do put a lot more time into C++ than CMake. Once CMake is kind of set up and running and I'm happy with it, I'm kind of happy just to leave it there. Thank you, good spot. Glad someone's paying attention. I'm just going to, there's a myriad ways of doing this. We could copy I'm just going to build them up byte by byte because I think it's more self-documenting what the code is doing. So we're going to have an integer. Okay. I suspect it will not like that because cannot convert integral types to a byte. So here's a fun C++ fact for you. Std byte is pretty much, or I don't know if it's guaranteed to, but it is in every implementation I know, implemented as an enum. So enum class byte char, which kind of gives it all the benefits that you want of a byte. Is in there. It's an opaque type. It's exactly 1 byte. You cannot sort of read from it. It cannot be accidentally implicitly converted into an integer. That's kind of why I use byte, because it's this sort of opaque representation of binary data. But because of that, you can't really do this. We could do std byte like that, but it's going to be a pain doing that. So I think what I'm going to do is do something like this. Template auto create binary vec, and then that's going to be what? Args. And then we should be able to do then we should be able to do something like actually then we can then just return stud byte args. So this will basically, given an arbitrary number of things, it will try and cast them all to a byte and stick all that in a vector for us. I think that's what we want. So this should then become vec, and now it's a function, so I have to get rid of that. Yeah, more template magic. I've got. I can't not put some template magic in a bit of code. I do apologise. Fold expression. Yeah, well, I mean, yeah. I'm just expanding the parameter pack. I don't think there's any need to like fold over. I don't know what operator you would be folding over unless it's like the comma operator. A user-defined literal is an interesting way of doing it, but this is my poison, is template magic. Okay, interesting. The standard does define it as an enum class byte of unsigned char. Okay, interesting. It's hard to know sometimes what what the standard mandates, and then just like what everyone happens to have done. Do you know what I mean? Can we use ranges? We've not used them yet. I'll try and get some ranges in. I do like ranges. Okay, so now we should be able to let's call this valid. What should we do? Assert equals entry dot unit32 value ox aa bb cc dd, and that should be that. So the problem with type defing the unsigned char byte is that you don't get any. I'm surprised that fails, but we'll have a look in a second. You don't get any of the advantage, like what they were trying to achieve with byte, which is like an opaque type that isn't implicitly convertible to integers. I mean, ranges is a whole library. Was a whole section of the C++ standard library that deals with working with effectively. I mean, a range is just a pair of iterators conceptually, but then there's all the algorithms that kind of go with that. Where have I gone wrong? Oh, I've not actually given it the data, have I? Perfect. Now there. I think I can do. Oh no. Is it assert throw? And then this would be game exception. Why is it not like that? There you go. Cool. Okay. These magic values are just test things. Like I wanted to test that I could pull out an integer, so I just picked a random integer. It was the one I normally pick, and then I just little endian encoded it into this array. And now we could potentially parameterize. We could make ourselves lives a little bit easier by potentially parameterizing these tests, but I can. I'm again not a G test expert, and I think I'd probably spend more time looking that up than actually doing it. So for this, I'm just gonna do the advantage of using this is because it's a template, it'll accept any type, so I can just put chars in here, and then this should work. String type. And then again uint32t fuct string uint. Okay. So yeah. Oh, good point. I also want to test for an invalid int where we pass in only 3 bytes. Yes, that's a good point. Good spot. Uint valid, invalid, type, and then type size, and then that should also do the same. Nice. Okay, getting there. So hopefully now you can kind of see like the crux of how this works. The entry is just a way of associating a type enumeration with a bunch of bytes, and then the associated method for decoding it. Again, we'll add as we go on, probably like a vector 3. If we needed, we could have a matrix. You could even do something more complex with aggregate types. So you could have like a game entity which had a position and a model and a thing with textures and blah blah blah. There's nothing to stop us keep adding more and more of these. But that's kind of enough to get started with. So now we want to do the reader. So again, the reader just takes the span of bytes, and then it needs to return. It needs some way of accessing this data. It needs some way of returning entries from it. So my kind of initial thought for this is to do something like auto. Actually, hang on. Let's do TLV iterator, right? And have auto begin TLV iterator. So if we can construct an iterator for our TLV, which shouldn't be too difficult because we know the sizes of everything. It's quite easy just to kind of advance through them. Then we can add a begin and an end method, which means we can then do a range-based for loop over it, and we can loop over everything. And then we can use ranges to be able to search for things. That's kind of my view of this. So I think we kind of only really want to access reader through iterators. You can add loads of other stuff to it, but I think as a kind of basic start, this seems like a pretty good way of going about it. So in modern C++, iterators are concepts. So you don't have to have the weird tags or anything in them anymore. You can just basically, as long as you conform to the, hang on, let me find it. So there's a bunch of different iterators, right? Ignore the word legacy here. This is just because CPP reference kind of had a name clash and they had to put something else in it. There's different types of iterators, and each one has like kind of adds more and more functionality with more and more restrictions effectively. So you kind of got forward iterator. So this is an iterator that can only go forward. You've got bidirectional iterator. So this is an iterator that can go forward and backwards. A random access iterator where you can use the square brackets array syntax, what you want to call it, to access a specific element in constant time. And then contiguous, which is kind of like the most, I guess, powerful, kind of has the most functionality in it. I think we just want a forward iterator. I don't really care about, we can't really do, not easily, no, I don't think at all, can't do constant time random access. I don't really care about going backwards, like we're literally only going to want to go forward, so we can keep this super simple. So this here is a C++ concept. This came in C++20 along with ranges. So as long as we conform to this here, it is incrementable. It has a sentinel, blah, 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 derived from blah, 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 a bunch of other stuff, right? We will have a forward iterator, like, and then any code that expects a forward iterator can then use our code. So I think we'll start writing some of that. So it's not a CPU reference having a name clash, that's the language having a name clash. The definitions of iterator pre-20 were slightly wrong and unusable, so they had to be refined. Interesting. I thought it was because I did look up before, like, why do they have legacy? I thought it was because CPU ref couldn't have effectively a page for both forward iterator, the old one, and forward iterator, the concept. So they renamed them legacy, because I don't think the word legacy is used in the standard. I could be wrong, but it's kind of irrelevant. I'm happy to be wrong on that. That was just my understanding of it. But what this does mean is that we can use we can just static cast this to be stood forward iterator TLV iterator. And then basically we should be able to get the compiler to kind of drive us towards the right answer of what we need to implement. We're using C++23. I guess actually something probably needs to include this first, doesn't it? Otherwise it's never going to get there. I actually want to do it. Yeah, I'll put it there, but I actually want it in the tests, don't I? Here we go. Right. Okay. Oh, I put it in the wrong place, haven't I? That's my fault. That should be I don't think you can just slap static cast wherever you static cast. What am I doing? Sorry, static assert. I think I can put it there. Yeah, so the new ones are, the old ones were left as input operator, and the new ones are added as CP17 input operator. Okay, fine. Yeah, but then I think on CP reference, when they go to generate their pages, I think they had to add the legacy keyword to disambiguate them. Here we go. Right. Note the concept for iterator evaluated false. It's because you cannot dereference an operand of type TLB operator. Okay, so this is basically saying there's no dereference operator, so there's no way to get anything out of this, which is understandable because we've not added one. So auto operator star const is TLV entry, right? So when our iterator should yield us out an entry, something that we can use. Obviously, how that actually looks is kind of TBC, but but that's kind of the interface that we want. Yeah, double exclamation mark or bang bang in bash will just execute the last command. It's really useful if you need to run something as run a command. It's like, oh, you need to run this as sudo. Then you can just do sudo bang bang, and it'll rerun the last command as sudo. Why did it not like that? Thank you. Even after I went through earlier about what all that means, I forgot it. But now we need the difference type. So this is just how it can, the type it should use when, it's the type it should use if it's looking at the difference between addresses of subsequent iterators. So using difference type equals, just use what everyone else uses, which is pointer diff t. There's no TLV reader CP file. Yes, I'm aware of that. We'll add it later. We'll add it when we get the link errors. I'm just trying to get through this first. Oh, hang on. Did I put it in the wrong place? So now we need the additional, so for an iterator to be a forward iterator, you have to be able to advance it or make it move forward. So you do this with the plus plus operators, but you have to define both of them. So I will get this the wrong way around, and then I'll go and check it. I think that's already wrong, right? So there's obviously two plus plus operators. There's the pre-increment and the post-increment, and they are handled differently, as in you can overload those separately. So the way you disambiguate those in the language is if you take an integer that is defined as the pre-increment one, which always returns a new value, and then the post-increment modifies the existing value. I think that's right. Good spot. I think that's right. Let's double check. Yes, I think that's right. Okay. We are getting there. We're getting there. We're getting there. What's my opinion on potentially adding a rewrite rule to, if it has no post increment operator, to use the pre-increment one to synthesize one? I think in the same way that we already have that, if you provide a default equality operator, it will synthesize the inequality operator. I without looking too deep into the consequences, I can't see, considering everyone's pre-increment operator is basically temp increment return. I can't see any reason why you wouldn't do that. I think I've gotten the wrong way around, actually. Am I the post increment returns the new value? Yes, sorry, the post increment returns the new value, which is why the pre-increment is considered more efficient, but the compiler will normally optimize out. That's it. Sorry. Yeah, I'd be okay with that. Anyway, what was my error? Input iterator, value to false. Input value to false. So false. The game TLV entry ref and TYRF are different types. Note: expression resolved call operator plus plus. TLV Raider line 22. I mean, that hopefully that made sense to everyone else. Is it because I just nope? Oh, wait a minute. It's because it has to return. Sorry. Has to return another iterator, doesn't it? Because if I add one, if I increment my iterator, that shouldn't dereference it. That should just return me a new iterator, which is one further along. Right? Am I going mad? Okay, now I'm missing iter value, which is fine, because iter value just means it's expecting another alias of value type. So using value type equals TLV entry, and then I guess to be good citizens, we should actually just return value type there. So we're nearly there. I think we've nearly written an iterator. Well, define the interface one. We still got to implement it, so there is no code at the moment. Hello, glad you're here. Are we at link errors? These. Oh no, I now need. Auto operator const TLV iterator const equals default, because you have to be able to tell if one iterator is equal to the other. Otherwise, how would you know when you're at the end? As in, how would you compare against end or anything? Built-in operator cannot be applied to operator types. Oh, hang on. Twisted by my own petard by forgetting to put that in there. If I considered using a sentinel instead of a regular iterator for the end return value, that's a good question. Have I? No, I've not. Purely because I don't think I've done it that way before, and this is in my mind how I would do it. That's a good question. What I'd probably do is I'd probably have to double check like the semantic difference around like how it would actually look in code, and then I'm not opposed to it, but traditionally when I've done stuff like this before, I've normally just created like it's effectively a sentinel in itself, I guess, like a dummy end one that represents no value, and then compared against it. But that's a good point. I will look into it. It challenged me to be better. Okay, so that works. Oh, if it's that simple, then I'm happy. Yeah, let's give it a go. I'm happy to learn something new. So struct TLV iterator sentinel, and then operator const TLV iterator sentinel. I probably have to. I don't think I could default that then, right? It would make life easier because do I not still need to? I still need to be able to check equality between other. Why would I not need this still though, right? Because surely part of the concept is that they are equitable. I'm going to stick with the way I'm going to in my mind to start with, but I will only because I don't want to get too distracted on that. I think that's something that I would double check, like the semantics of myself, and then maybe we can go back and add it later. But it's a good point. Yeah, I think I still need this. So anyway, well, let me have a look into it. It's one of those things I'm more than happy to kind of go away and do a bit of research and come back like better equipped for the next stream. Okay, so we got the concept now. So now we need to go and implement all these. So we will need, as someone has pointed out, a TLV reader.cpp. TLV reader. Let's bring in some of this stuff. So we're going to want that. Reader colon begin dot end dot. Okay, and then I'm going to want to bring in all these. I think I can do auto TLV reader, TLV iterator, operator const TLV reader, TLV iterator, value type. And then I want this for all of these. So this will be TLV reader, TLV iterator, and put that there. And then, yes, I know it's wrong. Oh, I've been making up some extra types here. What have I made up here? Okay. TLV. To be honest, I think this is incorrectly named. I suspect this should just be called iterator because it's scoped to TLV reader. Sort of unnecessary duplicating. Okay. And save that file before I forget. Okay. So this will just store our buffer somewhere. Keep it safe. Keep it secret. And then, oh my goodness, right, now I actually have to think about this. What does the iterator actually look like? The iterator is going to have a span over the remaining bytes, right? So every time we increment the iterator, we'll advance. So if we've got this many bytes, all right, every time we advance the iterator, we'll just slice off that many bytes, and this will be the new span internally. Yep. So, I mean, we can at least start with that. I think that's a good a go as any. So let's do stud span constant byte buffer. So this is going to then need a constructor. Really should have aliased this, but here we are. Spans to byte buffer. Stick that there. TLV reader. And then buffer, excuse me, buffer. Okay, so okay. Hello, first time chatter. Glad you're here. Okay, so now he says simply, easily. Why is it not like? Oh no. Stud span doesn't have an equality operator, does it? No. Okay, fine. Do it the hard way. I'm sure I looked this up before and I can't remember it. There's a reason they didn't. I believe it was a deliberate choice to not include an equality operator with std span. I forget what it is. But for us, I actually only care if effectively the subspan is the same. So this should be easy enough for us to do. Other dot buffer dot data equals buffer dot data, and while we're here, we might as well check the size as well. Other dot buffer dot size equals buffer dot. Yeah, that rings a bell. Do you want it to be the same span or the same values? As in, conceptually, if I have two spans over the same range of numbers, are they the same, even though they're different spans? Or, sorry, two spans over two different numbers, but the numbers that own them are the same. Are those equal or not? For me, I actually care if it's the specific raw data under the hood, because I'm going to be using subspans as we go along. What resources would I recommend for learning modern C++ features? Decent C++ when it comes to the base set of stuff, but pretty much nothing about modern C++ stuff. It's really hard because, like, what do you define as modern, right? So you kind of C++ 11 was modern, and a bit now you got 20, which I guess is like what, postmodern. There's loads of there are loads of good blogs and articles and stuff on how to use like new features. So if you go try and find go to Wikipedia and look at look at the high level new features that were introduced in each of those languages, and then just pick one of them and have a play around with them. So like, I don't know, C++ 17 had optional, so like go and learn about that and have a play around with it. CPP-ref is still a great resource for these things. Like there's loads and loads of new stuff, so it's kind of hard to understand where to start, but I would just get the high level, like the cliff notes of what was new in each version. You don't have to worry about like the minute details and the subtle changes to the wording. But get like the high level language and library features, and I guess just like, have a play around with them. Okay, so that'll be enough for me. So begin then. So this should just return the full buffer. And this should return an empty buffer. Oh, will this then work? Let me think about this. What should my quality operator now be? No, actually, I don't want that. I want to return the end of the data, right? So I want to do buffer.data plus buffer.size. Yeah, that's what I want. So the end will be effectively a zero-sized span pointing one past the last element. I'm not sure how I feel about tight-lipped vector as a TLV. Okay, so now this equality will work because the pointers will all match up. But yeah, effectively the end will be like a zero size span, one pointing past the last element of the buffer, which will also work then if you pass in an empty buffer, I think. So this one's easy. So auto temp equals this plus temp return temp. Sorry. This, because you still modify yourself, you just return the old object, right? Yes. So how do you actually advance this? What we need to do is we need to update the buffer span to point to past the last consumed object. Let's come back to that in a second, actually. So operator start. So what's our entry? We need to construct an entry based on the data we've got. So for that, we will need to do error. Missing a bunch of includes here. So we need to ensure that we have a valid entry, which means it has to have at least enough bytes for the length, for the type, enough bytes for the length, and then length number of bytes. But actually, we don't need to worry about checking that because the TLV entry itself will check that there is enough bytes for it, I think. Anyway, let's just start writing some code. So I want the buffer.size has to be greater than or equal to size of TLV type plus size of stud uint32t. Yes, in fact, I think that's all you can do. Because you cannot know a priori how many bytes are valid for the type without doing all that checking in here, and that's not really the responsibility of dereferencing the operator. The object it produces is responsible for checking the validity of it, if that makes sense. I don't want to duplicate that effort. So now we can just do auto type equals TLV type stud mem copy. So we can just copy it into the bytes into that. Sorry, we can copy the first 4 bytes because we know there's at least 4 bytes into the type. So that would be what's it? Buffer dot data size of type and then auto length equals stud uint32t and stud mem copy into the length buffer dot data plus size of type size of length. So what we've done here is effectively gone this many bytes past the start and copied then the next chunk of bytes. I mean, they're all 4 bytes, so we can just talk in absolute terms. We've gone 4 bytes past the start of the buffer and then copied another 4 bytes. So that's the type, the length, and then the remaining, the length bytes is the effectively the subspan that we pass into the entry. So we got the type here, so we can do type, and then we need to do buffer dot subspan, I think, and then it's the check. It's the offset and then the count. So the offset will be buffer.data plus size of type plus size of length, right? Because that's past the bits we've already read. And then the length, the count will be length. Hopefully I haven't lost anyone. Okay, fine. So that should, given a iterator at a current point in the blob of TLV entries, because all these TLV entries are next to each other, this will construct this object with the right type and the right subspan of data. It is then the TLV entry's responsibility, which we've already done and unit tested, to make sure that those data is valid when you try to effectively yield out a value. Whew. So plus plus. When we increment the iterator, we need to advance this by the size of the previous TLV entry. So what I'm going to... equals I want to, this is quite cheap to do, right? It's a bit of mem copying and stuff. In the grand scheme of things, I don't mind duplicating this because this gives us all the information we need. But I can't do star this because that will give me a copy of the iterator and not call this. I think it's gross, but I think I can do that. to get a TLV entry. Now I can do buffer equals buffer dot is it last? It is last, which will skip over the n bytes, which will be size of TLV entry plus size of std uint 32t plus I don't think I exposed this bit of guilty knowledge here, but we'll value size I'll keep it. Std uint 32t. Actually, no, I've changed my mind. I want to do size, and this can return its own, this full size that it requires to represent that TLV entry, rather than leaking specific internal information. So we'll do entry dot. We could just. We could. We could just duplicate this, right? We could just skip over the first 4 bytes because we don't care about the type. We could just copy out the length and then we could just advance by that. But I feel like I'd rather, the less mem copying the better, right? I don't know, maybe a hot take. Not a C or C++ programmer, but you find this work fascinating. I'm glad you're here, and I'm glad you're enjoying it. Also, it's not very often you get to write operator star, so you know. And then what? Now I can do return this because I actually want to return myself as a reference. Why is it expecting a... Close brace. What have I missed? Anyway, let's stick this in the CMake hole and get it building. Blah, well done. Missing. I am missing a. Where am I missing a brace from? Let me just close this down. Oh, so that should be. No. Yes, you're right. It should be iterator. Okay. Oh, I was trying to parse this, you know? So it now no longer likes my no longer likes my iterator. What's this? 922. This is not the issue, but I'm just going to tidy it up while I'm mulling over the issue in the back of my mind. Still thinks I'm missing something. TLV 24. What was that? Oh, hang on. Taking a screenshot. There is no context in which this conversion is possible. Cannot convert from stood byte star to stood. Oh, hang on. Just missing more curly braces. What I was trying to do is I was trying to pass the two arguments for the span as the arguments for the constructor, but this only takes one, so it's like this. There is no possible way this could work. Whereas if I put in another curly brace, it will reduce the type, pass those on to the constructor of the span, and then pass that into the constructor of the iterator. I'm glad. I feel like it could have told me that, you know, like in slightly clearer terms. Theory 42. Line 42 needs at the end. I think Quoco's solving all my issues for me. Yes, correct. Missing a bracket there. And End of line 61 need dot data. Oh, yes. Correct. How do I figure out what to write, or do I have notes for libraries written down? It really depends on what I'm doing. I've written this stuff kind of before, so a lot of this just kind of rolling around my head. I normally have a bunch of notes off screen for various bits and pieces that I normally think before the stream starts what I might need, and I have them kind of ready in tabs ready to go. Yeah, but I try not to do too much pre-prep, because then you kind of would miss out on the joy of watching me struggle with all these miserable C++ template errors. Okay, right, so we're getting there. Don't care about the static assert. I'll fix that later. I think that might be a symptom rather than the cause. Line 42, cannot convert from const byte star to const span. Okay, if I just got on the arguments. I didn't. Let's ignore that. Okay, it's still not, it doesn't like this 42. There's very much an issue on line 42. Which is the entry constructor, right? It should have a type and a span, and I pass it a type and a span. Oh, wait a minute, it's... Yes, it's not a pointer. Subspan takes 2 integers. It doesn't take a pointer and an integer, that's why. Do I have a theory on why the games industry still uses C++ instead of switching over to another, language? You said easier language, but I have no opinion on it, but I think all programming languages at this kind of level are hard, such as Rust. I think there's a couple of things. One is there's a huge amount of institutional and tribal knowledge. Like all those developers know C++, so it's easier to keep using that. Two, all the tooling and libraries is already written around that, so it's just a huge effort to switch to something new with probably minimal, like, you're going to pay a huge amount of cost to get there, and then you would be ages before you start reaping any benefits from it, I would suspect. Okay, why is it not liking my concept now? It's saying all of them evaluated to false. Why is my static assert something failing? What have I changed? It's weird because it was fine before. It was fine when I just had the declaration, right? once I just declared all these and they were fine, but once I added the definition, it was like, no, I don't like it. Why? Anyone see my issue? What have I missed? What have I missed? I've missed something here. TLB reader to return to false. Static assertion failed. It's saying it's no longer incrementable. I find that very hard to believe. Operator star for us does not need to return a reference because what would it be referring to? It needs to return a new TLB entry. It's really strange. I'm kind of tempted to just... Hey, What's... It's also saying it's not a regular type. Copyable default default constructor. Do I need a default constructor? Yeah, I think that's it. Yeah, that's it. It's no longer default constructor. Watching this at 480p, I feel sorry for you. Can you actually read any of the text at that? Okay, right, so we've got a chance of this all working. Let's try some tests. And I think by the time if we get these tests working, I think we'll probably... I knew this was going to take a while and definitely spill over into multiple streams, which is fine. Kind of wanted to just get down and just do some fun low level-ish C++. The writer won't take us too long to do at all. Okay, let's do... I should probably... Okay. These should definitely all be separate files, but I'll move them later. I'm not too fussed at the moment. Okay. So we should be able to do... Let's create a valid entry for... the for an integer. Sorry, got that in. Right, so it's going to be OXO, 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 and then OX04, OXO, OXO. So this, in theory, I'm hoping this doesn't all get destroyed when the formatter kicks in. Ugh. I would really like those to be on separate lines. Fine. Okay. I'm not going to fight the formatter. This is the type. This is the length. And this is the value, right? So 0 is the type. 4 is the length, and the value we want is that. So that is the single entry that we want. So let's do const auto reader equals game TLV reader bytes. Okay. Now we'll do const auto begin equals reader dot begin, and then we should be able to do something like assert equal begin dot type equals game TLV type uint32 assert equals, although we kind of already tested this, but I'm just going to just do it here just to be super sure. Dot get, sorry, uint32 value equals what am I doing? OX A B B C C D D. Conversion loses. Oh no. Right. Okay. TLV does stand for type length value. Okay, so the problem here is that I have arguably correctly created a const reader because it doesn't need to be mutable. Sorry, okay, I've created a const reader, right? Now I want to call begin on it, but I've not had a begin, but begin itself is not const. So what you normally have to do, right, is do this, create a const and a const overload, and then basically duplicate this. However, let's do something fun. Let's in as of C++23, there is a no, don't need that. There is a trick we can do which introduces this special syntax here. So in Python, you know that when you have a member function of a class, you have to specify the first member itself, right? That is just how the language works. You have to be explicit about the first member. C++ classes also have a first member. It's called this, right? And that's why you can do this, blah, blah, blah. But however, it's implicitly created for you. If you look at the assembly, you'll see that the pointer gets passed in as the first argument silently for you. C++23 introduced a change into the language, something that's called deducing this, which allows you to be explicitly give the first argument, okay? So this now has self. This might seem strange, and it is strange, but what this does is, because I've used auto, this is effectively a template, which means this function will get, this template will get instantiated for every type that's passed into it, and the rules of deducing this are it will deduce this to the correct type and value category. So if I call it on a const, it will generate a const version of this. If I call it on a non-const, it will generate the non-const version of this. And it's also true for value categories. It will do our value reference overloads and stuff like that. So now all I can do is I can just do this and remove it from this, and I only have to implement it once. Now notice here this is an error because of the way deducing this works. Is because it no longer has access to this explicit this, I have to actually go everything via this new self variable that I've created. This self variable is, I could call this whatever I want, it's just convention to call it self. but then this just kind of gets rid of that. Anyway, so that's a little C++23, so C++23 treat for you. So that G duplicates a little bit of code for us, which is quite nice. I think this is still a reserved keyword. So this you cannot use this here. This being the this keyword. So yeah, anyway, that's a fun little extra for you guys. So if you've not seen that before, if you have seen it before, then here's a good place to use it. I'm still missing a method, aren't I? Didn't I create like entry entry? Didn't I create a size method that I now need to implement? So I think someone's saying, yes, you can just use this keyword. I didn't think you could. I could be wrong. I tried just then, I got an error. But all the literature I've read on it, and including the original paper, seem to use self. So that's what I've kind of done. But I'm happy to be wrong on these kind of things. Return. So this is the size of type. The size of std uint32t plus value dot size. Okay. Whoa. That's my little YouTube window which tells me viewers and stuff. Didn't mean to splat that across the screen. Sorry, just saw that there. Just fix that cast. I've chosen to narrow the type just because we were using std 32 T's for everywhere else. I kind of made the decision to keep that consistent. Type is not a member of iterator. Test. Oh. Of course, because I need to get the type out of it. That's what the star operator does. Oh, look at this. Gross. So many brackets. Thanks, C++. Size can't be const because if it's a string, I won't know a priori how long the string is. Okay, nailed it. So that works. So let's try. let's do a string as well. So let's do. So this will be. Technically, I should not hard code these values in case they change in the underlying game TLV type uint. Just prevents if we have a what I don't want to do is to change the order of these, then have all the tests break. There's not too much hard-coded stuff. I mean in the game, once we've got this data structure done and we add sort of aggregate types, we can then use it to represent a scene. So we can then start, building up scenes into files and stuff. Horrible feeling I've gotten this the wrong way around somewhere. Yes, I have. Right. Okay. So 2 and then I think the best way of testing this, because I guess it's not just enough for it to compile. For const auto entry in reader. Good spot. Yeah. I thought I'd remove that. So good spot. So what's the reason for not implementing a start flag and end flag with strings? Do you mean like sentry characters, like the null terminator? Like there's no need to, because I encode the length. Like I literally just say how long it's going to be. So there's no need for any additional data. That's the it's the L in the TLV. I want to go. I just want to make sure it goes through the mechanics of looping, which will test the increments and everything. It's a little bit gross, but looking at the time, I think it'll suffice for a test. And also, I've not written any ranges yet. Not my finest test, but basically it will check that there are 2 entries in there. I could manually just do this with the iterators themselves. I could pull the first begin out, check it, advance it, do it. But I feel it's kind of nice to check it works with all the other parts that we're going to want to use it with. I don't know if there's an assert not reached actually. I've just always used assert true false, but we can have a look. Oh, sad face. At least this way it'll tell us exactly which one was wrong, because they're explicitly called out. Assert failed. Count out of range. Is this data wrong? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3. Oh no, hang on. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Yeah, so 2 underlying will output 4 bytes, but don't remember we have a templated method at the top which will cast it to a stood byte, so it doesn't matter what integral type. This should probably be user concept, which is like stood integral, but I really don't care for test code. So this will cast it to a byte, so it will just slice off the remaining bytes. What was that thing where you made the function both constant and non-constant? The feature of the language I used is called deducing this. 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. I think we'll get this working and then we'll call it there, because it's been a couple of hours doing this, which is fine. I think it's all stuff we need to do because this will make our lives a lot easier going forward. Type length value. Does the loop start with an offset? As in, we'll call begin, right? So TLV reader. So it starts off with the whole buffer that you pass it in. Where does it call? Okay, where does it call subspan? Because that's calls it here on the dereference operator. I use Fira code with the ligatures, so it's like this is out of range, and this is the only use of subspan, so it has to be this line, okay? It's a little endian though, isn't it? So don't you put the won't the length go first? Because I'm laying out the raw bytes for the integer, which is why up here I specify DDCCBBAA and then I check AABBCCDD. It's a good point though, like it's worth double checking. Yeah, okay, fine, let's just check. I would be surprised. TLV type is an enum of supported types that we can encode in our object, in our structure. Yeah, I didn't think it was the case, but we'll leave it out for the moment. I think we might. I would normally. So now is the point I would use a debugger. However, because of my weird setup that I've been playing around with, it's not actually that easy for me to attach a debugger at the moment. I would have to copy it all out to the Windows side. Probably the easiest thing for me to do is actually push it up and then put it down in VS Code, which we might have to do in a second. Why am I doing the series? Because I think it's fun and hopefully people learn something interesting along the way. Count is out of range. So this is wrong. But what's interesting is that I didn't get any of this with this, right? Where it just had this packed into it. Line 38 there. Yeah, that doesn't look right, does it? Because what am I doing? I'm taking the. Yes, I think you're right. It is that because I'm saying. What am I saying? That I need to move it past. Yeah. Yes, this is right. So what I'm say this returns. I want to advance it this many bytes forward. What I'm actually doing is taking that as the last byte. So say I have 100 bytes and this returns 10, rather than moving past the first 10, I'm actually shrinking the whole thing down to the final 10. I think what I need to do there is do buffer.size minus entry.size. No, I think it's the problem is I've gotten the semantics of last slightly wrong. Yeah, there you go. Nailed it. Boom. I think that actually for a couple of hours work is pretty good. Yeah, thanks for whoever pointed that out. I think two people did. I think it was Julian and Das Candy. Thanks. Good spot. I think that's pretty for an interface. I think that's pretty good. So now it's basically super. I'm going to say something. Hang on, I've got a thing for this. I think it's quite trivial for us to do the writer. I say trivial, like, because all we're going to do is take all the types in TOE types and then write all these out. That's why the writer is not nearly as interesting. It's super easy to unit test, and we can go through all that. And then what we can do is we can write a test which round trips them, which is always interesting. So can I write something and then read it and check it all kind of goes the right way around? Yeah, I mean, I don't know. I think that interface is quite nice. Like, it works with the default. It works with the ranges. It works with it should work with ranges. We should be able to do like std ranges find. It works with range-based for loops. It's kind of just it just feels like a data structure that we can kind of now use. You were promised ranges. Look, there it is in the test right at the end. I have no more need for ranges at the moment. So yeah. Oh man, if you have to use std launder, you've got bigger problems. I think was it described as like if you don't know what std launder is, then you definitely don't need it. I've never had to use it in anger for cleaning my dirty pointers, or well, not pointers, but memory access. Hopefully we won't need it, but if we do, it'll be fun. But I think we got through some good stuff today. Like, I'm quite pleased we got to use deducing this, which is don't often get to use. So yeah, it's a nice little addition there. So switch back to that. I've seen 2 correct uses of std launder in my lifetime, not needed for this kind of data structure. No one needs. You do not need launder for this. I think you're doing something. It's also like the pointer to member syntax. Like, I've only ever seen that used in Angular like once or twice. So I'm never convinced it's the right option. But anyway, I hope everyone enjoyed that. What's going to happen next? We will. Hang on, I've lost. What's going on? Lost my train of thought there. Sorry, terrible for a stream. Yeah, so I'm pretty pleased with this. I think we've kind of got something now where we can start encoding data. So what we'll do next stream, so that should be Sunday, is we will look at integrating this into the actual game. So we'll where is it? We'll expand this for other types that we need. We'll add arrays to it because we'll need to be able to take, for instance, the index array will need to be an array of these, and then we'll add like vector 3 to it, and then we'll add an array of vector 3 to it, and we'll kind of start doing all these. We'll start fleshing this out a little bit more, but we've got most of the mechanics are in place now. It's just a case of extending this and adding these. We could add aggregate types if we need, and then we'll stuff in a texture. We'll write a program which can pass actual textures off disk, convert them into this type, and then we'll get the game to load it. So we'll kind of make sure we got all that, and then we'll just finish like fudging it into CMake so that it all kind of works nicely. So I reckon, and I'm hoping only one more stream on this. We'll see. And then let me quick check the to-do list. What's on the to-do list after this? So we'll finish off the asset pipeline, then I think physics. I think we're going to try and integrate a physics engine. I'm glad everyone enjoyed it. Thank you. Sorry, nice comments coming in. Yeah, I think we'll integrate a physics engine after this. So that'll be more to actual something visual. I don't really have a good screenshot for this for the community post. So I might just miss this one out. But yeah, we'll anyway, I'm rambling a bit. I think it'd be nice to be able to get like a little level that we can kind of walk around in and push those. I think we need to be able to push those barrels around a bit. Those barrels have been static for far too long. We need to attach a rigid body to them and start shoving them around a bit. Yeah, that's all I've got today. I hope everyone enjoyed it. And I will catch you all in the next one. Thanks very much. Enjoy the rest of your day or evening.